In this series of videos, we're going to learn how to integrate certain interesting integrals. So as a first example, we can talk about how to integrate these two. So the first one is x plus 1 over x dx. The second one is the same thing upside down, x over x plus 1. So we can use like an interesting strategy to solve these two integrals. So let's see how we can do it. So the first one, as the first one, we have the integral of x plus 1 over x dx. So the idea is we can split this into two terms. So we can write this one as, if we divide by x, so we can write this one as x over x plus 1 over x. So we put parentheses around because there are two terms here. And then you can see that this is simply the integral of 1 plus 1 over x. And we know how to do both of them. So the integral of 1 is x plus integral of 1 over x is very interesting. It is ln absolute value of x. Don't forget the absolute sign. And plus c. We don't have 2c, we see 1c. So that is the solution of the first one. So let's look at the second one. So as the second one, we have x over x plus 1, integral of x over x plus 1 dx. So it's the same thing, but upside down. You get the reciprocal. So the idea is, what we're going to do, we're going to recreate the bottom term in the numerator. So that means what we do like a simple interesting trick. So we have x. So what we're going to do, we're going to add 1 and subtract 1 to get the same term. So you add 1 and subtract 1. And the denominator is the same, x plus 1. And then actually you can see that this can solve the problem, because what you can see is you can actually bracket the first term, so you put a parenthesis around it, and then you see it's the same term. It's the exact same term as the denominator. That means we can do the same trick as like you divide both terms by x plus 1. So you simply gonna get, you can see if you look at the first integral, so the first integral going to first term going to give you 1 minus the second one going to give you x plus 1. So there are two terms, and then we can integrate the term by term. So the first one is going to give you x minus, what is the second one? Second one, you can see that it is almost like the previous one, but you have x plus 1. So when you have a constant added to a term, it actually do not change the type of the solution. That means it is still ln, because like when you take the derivative, you can see that it's still x, and x plus 1 has the same derivative. So because of that, they have the same type of answers. That means the answer should be ln absolute value x plus 1 and plus c. So that is the answer to the second question. And then you can also see that you can use the same trick to solve these two problems. So why do you need to try them just for practice? So you can try these as practice problems. And the first one is say evaluate the integral of x squared plus 1 over x squared dx. So you can do the same trick, you divide. And the second one also, we have x squared over x squared plus 1. So the other way around. And you might need to recall this formula. So we know that the integral of 1 over x squared plus a square dx is the integral of, answer is 1 over a tan inverse x over a plus c. So that's the answer. So you might need that for the second one. Okay. Also try this one. The second one is this. So as the second one, we have the integral of x plus 1 over x squared plus 4. This is also very similar to the previous one. You can split this, but you might need a new formula for this one also. So there's another formula. So what it says that if we have a function and its derivative on top, you know that this one is simply the natural log of absolute value of the bottom function plus c. So this is the formula we're going to use for this one. And if you don't know those formulas, you can find the link in the description that talk about 4 formulas, and this is one of them. Okay, so you can try them, and I have given the answers in the description, so you can match with that. Thank you.